Hello, everybody. So, the topic I'm going to be discussing today is cloud computing. We're going to start with why cloud computing, how it started, where it is taking us to. So, if we answer these questions, we would be going to the depth or the deeper level of cloud computing and how it started, what it is doing in the current society. So cloud computing dates back not just to the 90s or the 80s. It dates back to 60s. The history starts right from client server computing. So, so cloud computing history. So as I was telling, it dates back in your 60s from your client server computing. What is a client server computing? So back then we used to have a client machine, and there used to be a server located somewhere in your remote location around the globe. And through the client machine, we would be able to access the resources that we want to process, whatever the resources that we want inside, or the computing resources we would like to perform, or the task we would like to perform in our client system. So back then, it used to be a centralized system where these requests from the client usually be directed towards a specific server through the network, and the client has to wait for a longer duration of time to access the server and to retrieve the data from the server. So later on, it went to something called as peer-to-peer computing. So here, as I told, in your client server computing, the data was centralized, which was to a specific location where you have to literally request the server, you have to find the server, the port number through the network, and you have to access the data. But in peer-to-peer computing, that was not the case. It's an improvised form of your client server computing, which enabled the user to perform some task within the devices that the user has. So say the user is using his personal devices, computer, or whatever the devices he's accessing the data from. So everything is accessible, or some form of computing services or tasks or the operations would be done within the client side. So you can call this as something decentralized. So the client server is centralized and your peer computing is decentralized. So obviously you will be having your servers holding your data, some important data for the computing to happen, and these servers uh, will serve the computers on higher level. So some important tasks, some task which requires higher performances will all be done by the servers. So your client and the server together will be viewed as a peer. So here you already have a server functionality running. So you view this node as a peer. So every peer does the client as well as server operations in it. So that's how it started. So there's no requirement to basically go for any dedicated server or a dedicated central machine which is going to be performing the entire computing operation. Okay, so from then on, we went to something called distributed systems. So the distributed systems were the first of all the other systems which gave an architecture to or which to the cloud computing technology or the cloud computing systems. So this basically gives you infrastructure or the architecture. So here there are multiple computers connected in the distributed systems architecture which works on a specific goal. So there is a common goal that would be given to these distributed systems which works together to achieve the goal. So it moves towards a common goal. So all the nodes works for a common goal, and it is completely decentralized. So when you have such a system which is working for a common goal, you can view or you can tell the system as something which is enabled to do highly parallel tasks or workloads. So there are some key features which enables the birth of cloud computing right from your distributed systems, which goes as follows. Concurrent. So all the tasks that gets executed inside your network will all be running concurrently, parallelly. So the resources would be allocated and distributed in such a manner that no one process should wait for the resource to be released for the other process to run. So simultaneously, there would be processes running their tasks concurrently, P1, P2, to n number of processes without interfering any of the processes or the resources that's been used by a particular process. So one more important feature that is gonna make distributed systems more comfortable to convert it to or shift it to a cloud system is scalable. You can scale up and scale down the resources as and when you require. So this didn't just start with cloud computing, it started back in distributed systems. You scale the resources based on your requirement. Say, I have an application to run on a distributed system which requires heavy workload at a given point of time. I might be running my application on weekends and it just requires more computing resources to run. So in those days, I can scale up my resources where I can increase my computing resources. So I have my computing resources, say your RAM, and you have the HDD, hard disk drive, which is the disk, and the processor. So this is the RAM and this is the processor. So these are the basic computing resources which we use or which gets allocated to all the processes basically running inside a network. So I can either add up on the resource or add down, which means I can scale up and scale down the resources based on my requirement. Having said that, so we have one more important feature which starts right from the decentralized systems, which is the fault tolerance metric. So there would be a number of systems running inside the network. There are chances like for the systems to go down or to totally on some hardware configuration or updates happening, so there could be downtime in the system where which wouldn't be accessible by the end user at a given point of time. In such situations, there would always be a backup node to give the data, to give the resources to the users, the end users, at any given point of time. So this creates an infrastructure or an architecture which enables the users to access the resources all time without any issue, even if there are some downtime on the server's end. So that's fault tolerance. Even if one node fails, there's always the other node backing up to serve the user. So I'm gonna just save this. So, so we started with client server computing, peer-to-peer computing, distributed computing, and now it went on to another important factor, which is clustered computing. So it slowly evolved to clustered computing. So it's almost similar to distributed computing, which is again gonna be a decentralized computing with distributed functionalities. So having said that, so this is gonna imbibe all the characteristics or the properties of distributed computing in it. So what could be done with such type of computings, which is going to be running the tasks parallelly, which is again scalable, where the nodes will always be the end users would always be able to scale up and scale down the resources, and it is fault tolerant, which means the nodes are always available to serve the user, the end user. So can we consider such type of systems to perform high performance workloads, tasks? So again, what you require to construct such a computing paradigm is networks, obviously. We have to configure the network so that the client and the server machines or the peers or the nodes that are running inside the distributed or the clustered computing paradigm can send and receive requests. So obviously, all the data that gets passed through the network from a client to a server or from a server to a client is all encrypted and decrypted for the security purpose, which we're gonna be seeing in detail in cloud computing. So this is faster in processing. So parallel processing starts here. There's again a huge research going on high performance task and high performance computing, which is specifically related to parallel processing, and it all starts from here. So scalability, where you can add on and add off the computers. You can scale up and scale down the computing resources as and when needed. And one more important feature that pops in here, which is going to be acting as one of the backbone of or one of the important functionality of cloud computing, is load balancing. So we had seen that there are n number of computers, millions of devices and servers connected. So each server has is gonna be performing some task based on the request from the user, and the user should be directed appropriately across all the machines so that the network is balanced appropriately and there's no downtime or to any given network because of loaded number of requests from the end user. So in order to do that, there's a technique which is used by the computing devices in clustered and distributed environments, which we call as load balancing. And load balancing is again nothing but is to distribute your workload. So the workload should be evenly distributed across the network so that there's no network that's going to be handling huge number of workload, and there's not going to be any network that's going to be having lesser number of workloads. It should be evenly distributed across the network. So from here comes the birth of cloud computing. So cloud computing is again gonna be doing all these functionalities that starts right from your client server computing to the clustered computing with more advanced features, techniques added to it. So what are those advanced features and techniques? As we had seen, compute, storage, network. All these things are seen as features which are accessed via the internet. So to know what cloud computing or to work with cloud computing, first you must have a good speed of internet through which you can access all these resources over the internet. You don't literally need to have all these resources inside your system. Say I have my laptop which is going to be having some amount of configuration. So I have an Intel core of i7 and I have NVIDIA GeForce, and I'm going to be having 4 GB of RAM, and my laptop is again going to process 1 TB of storage. Say I'm not going to be using all these resources at a given point of time, but still, if I would like to collaborate my application with my teammates or my batchmates when I'm working in my enterprise or working in my organization, or I would like to move my data to cloud where these applications can be integrated appropriately using the application programming interfaces, I can go with cloud computing. So there are various services provided under cloud computing technique, like your infrastructure as a service, platform as a service, and software as a service. So we can view this as an on-demand provisioning services. So say I'm working on a project, I would like to instantly use a servers which requires computing resource, a storage resource, a networks resource. I can immediately create an account in any of the cloud service providers which are given by Microsoft Azure, Amazon AWS, and Google Compute Engine. So I can create an account. I can just log into the dashboard. The console is going to be directing me to the data centers, which is going to be hosting the services, and I can just take the services provision from them. So this doesn't require any effort from the users. This is effortless from the users end. So again, we have various key features which makes cloud computing more robust. The first one is again scalability, where you can scale up and scale down your computing resources. Cost efficiency. I don't have to invest for the entire architecture in order to run an application on cloud. So I just pay for what I use. Say I would like to purchase 4 GB of RAM and some 2-core processor, say for example, and 500 GB of hard disk. I'm just going to be paying for what I use, not for what is available in the service. So this is going to be cost efficient for me. Accessibility. I can access it from anywhere at any given point of time if I'm connected to the internet. That's all is required. I would be able to access my resource at any given point of time. Say even if my local machine is off, I've been working on an application and I have uploaded it to the cloud. There's some issue, there's some downtime with my hardware, so I need to collaborate with my teammates. With just internet, I can access it from any machine. I can just borrow it from a friend of mine. I can just connect it to the internet and I can access from the machine. So whatever the data that we store in cloud computing platform from the service providers, either it's going to be Amazon or Azure or Google, it's going to be stored securely, where some specific encryption and authentication and authorization processes are going to happen. So there's going to be keys generated, and there's going to be some management system which is going to be managing all these keys, and they're going to store it appropriately so that it's not accessible by any user at any given point of time. So resource pooling is where the network is going to be having all the resources which will be at a given point of time when a user is requesting for a resource, it is provisioned to the user from anywhere. So this is again viewed as collection of resources, and these resources are given to the user for whatever the operation that the user is going to be performing. Say a user would want to use only the storage and network feature. So he would be there would be a container. So the storage and network would be stored in a container and it would be provisioned to the user. Say user 2 would like to use only the computing and storage feature. So that would again be packed in a container and it would be provisioned to the user. There might be users who would want to use computing and just the network resources. So even such type of users will be provisioned with a container which is going to be having only the computer network resources that would be given to that specific user. One more important feature that makes cloud popular or famous is the multi-tenancy feature. So I could give a real-time example for this where say there's a apartment and there are many number of residents residing in the apartment, but the residents are not going to be owning the apartment all by themselves. uh, so they're going to be staying there as tenants. So that's how the end users are viewed as in the cloud computing platform. We don't have to owe the cloud computing all by ourselves or the services given by cloud computing all by ourselves. All we have to do is just own whatever we require, stay there, use the resource how much ever you want or whichever combination you want, and just delete the instances, just terminate the instances or delete the resources, and you can just leave the service. So the policies and the principles are appropriately maintained by the service providers to provide the multi-tenancy feature. This enables multiple organizations to store their data in cloud with their data stored in a secured way. So the data is isolated from one user to the other user. So the data used or stored or accessed by one user is not going to be used or stored or viewed or accessed by the other user. The access control features are appropriately enabled through the multi-tenancy feature. The next feature which makes cloud more robust is your high availability and reliability feature. Say at a given point of time, there are n number of networks connected in cloud. I am trying to access a particular instance in a particular location, and the instance or say the data centers having a downtime. There would always be a replica of my instance in other data center or availability zone, and immediately I would be served with my data. So there's no situation where the cloud is not able to serve the end user with the requirement that's been asked by the user. I am requesting cloud computing resource which is going to be requiring heavy amount of operation or parallelized task. Say a given data center is just going to be having a limited number of resource. So immediately there would be other data centers at the footstep to serve the user, and reliable. I can store my data. I can trust that it's always there 24 by 7 based on the pricing and billing features that's been enabled by me. So there's no point at a given time inside your cloud service providing platform that your data is not going to be available. If with your intention, if the data is stored appropriately with the billing price or the billing parameter. So the next feature is flexibility. Okay, so this is particularly for various organizations to collaborate with each other and to make agile functionalities. So, working on projects, say a developer is working on module one, and another developer is working on module two, and another developer is working on module three, and all these modules has to be collaborated with application programming interfaces. In such situations, there can be instances created exclusively for all these modules, for module one, module two, module three, an API for your module 1 and module 2, and another API for your module 2 and 3, and for 3 and 1. So you can create instances for each of these modules and your APIs. You can collectively collaborate on the service, and you can execute your services on agile basis, where all the developers as well as the application programming interfaces developed by the developers can be integrated, can be worked on parallel environments at a given point of time. So in those days, that was not the scenario where a developer has to work on a given module and there's gonna be a wait time, or the other developers have to wait for the first module to get released, and then they would integrate it and they would proceed with the second module, and from there on they would go to the third module. That's how it used to happen back then. But these days, it's not like this, as the environments are totally parallel. We have millions of servers running behind to give the computing resources, the storage, and the network on demand at any given point of time. So there's no need to wait for any monolithic service. So this is totally microservice. So each developer can use microservices from the cloud, and they can start their instances and work on the application at any given environment at any point of time, and they can collaborate with greater agility. So this is what is about cloud computing, and this is the brief history of how cloud computing started. And in our next session, we would be diving deep into the service providers, the cloud computing models, and a few more things related to that. Thank you.